In this video we're going to look at solving quadratic equations that can't be solved by factorising. Not every quadratic can be factorised, and we need a method that we can solve other quadratic equations. Fortunately, there's a formula, the quadratic formula, which we can use to solve any quadratic equation. We're going to see this formula in this video and how it works. So the first thing we look at this quadratic equation is the coefficients, which is the numbers multiplying each of the terms. So our coefficients are 2, because we have 2 lots of x squared, 11, because we have 11 x's, and minus 5, that's the number that appears by itself. So there are coefficients. The number that multiplies the x squared is called a, so a in this case is 2. The number that multiplies the x is b, so b is 11. And the number that's by itself is c, and that in this case is minus 5. Now that we have a, b and c, we need to know the quadratic formula. And the quadratic formula tells us that x is equal to minus b plus or minus, that's where we get our two solutions. Remember, every quadratic equation has two solutions. Plus or minus the square root of, and all of this is underneath the square root, b squared minus 4ac, and all of that is over 2a. Okay, so now we substitute in our values. So we have x equals minus b, well b was 11, so it's minus 11, plus or minus the square root of, b was 11, so that's 11 squared, minus 4 times by a was 2, times by c was minus 5, and all of that is over 2 times by a, which is 2. Now let's do a little bit of a calculation. We get x equals minus 11 plus or minus the square root of 121, and then 4 times 2 is 8, times by minus 5 is minus 40, but we're already taking that minus 40 away, so that becomes plus 40. So there's two negatives there, 2 negatives, so we have a plus, and all of that is over 4. We then put this into our calculator one at a time, so we do minus 11 plus the square root of 121 plus 40, all over 4, being very careful that it looks exactly like that, and that gets us the answer x equals 0.422 to 3 significant figures. And then we do the other one where we use the minus part of the plus minus, so minus 11 minus the square root of 121 plus 40 all over 4, and that gets us x equals minus 5.92, both of those to 3 significant figures. So let's have a look at a second example. Now first of all, with this one we need to do a little bit of rearranging, because whenever we're solving a quadratic we need the right hand side to be 0. So this is the same as x squared plus 5x minus 7 equals 0. So that's our first step. Now this time a, what's multiplying the x squared? Well, it's 1. Remember, if we don't have any number, it's 1. b is the number multiplying the x, which is 5. And c is the number by itself, which is minus 7. Again, we now write down the quadratic formula, which tells us x is minus b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to minus 5 plus or minus the square root of 5 squared minus 4 times 1 times minus 7 all over 2 times 1. So x is equal to minus 5 plus or minus the square root of 25. We've got minus 4 times by 1 is minus 4, times by minus 7 is plus 28 all over 2, which gives us a final answer of x equals 1.14 and x equals minus 6.14. And that's how we use the quadratic formula to solve quadratic equations that can't be factorised.